All right, so what we're going to do is just that last example. I think we called it example 2. Is that right? We pretty much got to the end of it yesterday, but it seemed like I was kind of rushing through it, so let's just take our time a little bit here. All right, so it's called perpendicular transversal theorem. Yesterday we didn't even talk about the perpendicular part of it, but we will today. So we got two parallel lines cut by a what? What's the word? Transversal. Very good. Okay, so cut by a transversal. And then we got another transversal. But what's true about this transversal? This second one that I just drew. What's it look like? Oops. I've got to click off of that before I draw anything else. Perpendicular. That's the word I was looking for, okay? It's perpendicular, okay? You see this one right here? Let's name them. Call that one D, A. This is B and C. These are all lines. I'm just too lazy to put the arrows on them. Is that all right? Now, these two, though, I will put arrows here. What does that mean? Does that just mean they're a line? It means they're what? I heard it? They're parallel to each other, okay? So these two arrows right there means that B and C, lines B and C, are parallel to each other. And that's pretty important. Let's put some angle numbers here. So that's a 1, that's a 6, that's a 5, 3, 2, and 4. All right, I think that's everything. But they tell you some stuff, don't they? They tell you something about angle 1. They don't tell you exactly. Oops. Oh, that sounds terrible on the video. All right, we did. Okay, what did I say earlier? I said we did this yesterday. We're just going to finish it up. So we're just going to redo it. We're going to start it from scratch, okay? And we're going to, because I think I rushed through it a little bit yesterday. And they tell you something about angle 1. They tell you something about angle 2. They don't tell you exactly what angle 1 is, or they don't tell you exactly what angle 2 is, but they tell you this. They say that angle 1 is equal to 7y minus 15 degrees. So in order to find what angle 1 is actually equal to, what are we going to have to eventually find? Come on, look at this. Say it. I heard it. The y. I got to find the y. Okay, I got to find what the y is equal to. Everybody see that? So if I know what y is equal to, then I could find angle 1. What if y was, I'm just making this up, but what if y was equal to 2? All right, nah, it can't be 2. Let's say it's 3, all right? What if y is equal to 3? What would angle 1 be equal to then? What would you do? You go 7 times what? If I said y was 3. It's not, but what if it was? 7 times 3. What's 7 times 3? 21. 21 minus 16 is... I'm thinking of what the answer is going to be. 21 minus 15 is what? 6. It'd be 6 degrees, all right? But y is not equal to 3. I just made that up. But once we find y, we could plug it back in, and we can find angle 1. Once you find one of these angles, the rest of them are really easy to find. They really are, okay? But we got to find that one angle first, all right? That's a little bit tough. So let's find that one. So they tell you, this is what they tell you. I didn't come up with that on my own. This is what they tell you, that angle 1 is equal to that. They also kind of tell you angle 2. They say it's 10 times y plus 11 degrees. All right, so that's what angle 1 is. That's what angle 2 is. And what we have to do, we have to find the relationship between angle 1 and angle 2. We basically have two choices, don't we? Basically. Maybe there's 3 choices. They could be equal to each other. They could, maybe, all right? Or they could do what? What's another thing that our angles do in this parallel line cut by transversal thing? Add up to what? They could add up to 90, or they could add up to 180, right? Okay, so you basically got 3 choices. They could equal each other, they possibly could add up to 90 degrees, or they possibly could add up to 180 degrees. Don't really know right now, do I? So I'm going to go and I'm going to look, and I'm going to see angle 1, I'm going to see angle 2, and what I want to do is find the relationship between them. Again, I say that word a lot. I remember when I was a kid and I heard the teacher say, what's the relationship between that stuff? I had no idea what they were talking about. Relationship? Are they brother and sister, mom and daughter, father and son? No, it's not that relationship. Okay, what do they have in common? All right, so are they equal to each other? That could be a relationship, right? Do they add up to 180 degrees? That could be a relationship. You follow me on that? So when I say, what is the relationship between these angles, that's what I'm asking. Okay, what do they do to each other? Let's take a look. First of all, do you think they're equal to each other? Just by looking at the picture. Look at angle 1. What kind of angle is angle 1? It's an acute angle, isn't it? Now, let's look at angle 2. Do you think angle 1 and angle 2 are going to be equal to each other? No, there's no way, because angle 2 is a what kind of an angle? Obtuse. So can an acute angle equal an obtuse angle? No, it can't. Okay, so I need to find another relationship. Well, look at angle 2. What's really easy to see that angle 2 is equal to? 3. Why is it equal to 3? Give me a reason. It's not because it's obtuse. You're right, it is obtuse, but they're not equal because they're obtuse, yes. And I liked what he just did. He looked at his notes from yesterday, right, and he saw it. And that's good. I don't expect you to remember it just because we taught it yesterday, but he looked at his notes, okay, and that's what it was. They're vertical angles. 2 and 3 are vertical angles. What's true about vertical angles? They're equal to each other, exactly right. Do you remember what vertical angles are? Anytime you have lines that cross each other or intersect each other, you've got vertical angles, right? So this angle right here is going to equal this angle right here all the time. Everybody see that? The ones that are across from each other, they're vertical angles. Look at 2 and 3. Are they vertical angles? Absolutely. So what must be true about angle 2 and angle 3? They got to equal each other. That's right. So I could say this. Angle 2 is equal to this, but 2 and 3 are the same thing, right? So if I wanted, I could say angle 3 is equal to this as well. Do you agree? I'm writing this a little different than I did yesterday, but it means the same thing. Now, why in the world did I do that? Well, I did that because there was a relationship between angle 1 and angle 3. I've got parallel lines. Let me just draw it little down here, okay? I've got parallel lines, and I've got a transversal. That's it. This angle right here is angle 1. This angle right here is angle 3. They're obviously not equal to each other, agreed? That's acute, that's obtuse, so they're not equal to each other, but there is a relationship between them. Amaya said they're same-side interior angles. But what word do we use in this particular book? We don't say same-side interior, even though I like that better. What do we say in this book? Consecutive interior, exactly right. So they're consecutive interior angles. What did we learn the last 2 days about consecutive interior angles? Say it again. They're on the same side, but what's the relationship? Are they the same? They add up to 180. Give me a good geometry word, though. Supplementary, that's it. They're supplementary. So if I just said they're supplementary, what does that automatically trigger in your brain? What do they do if they're supplementary? They add up to 180. Everybody got that? All right? Saying a lot of stuff, saying a lot of words. You got to keep all that stuff straight. So 1 and 3 are supplementary because they're consecutive interior angles. What's true about supplementary angles? They add up to 180. So angle 1 plus angle 3 do what? Add up to 180. So here's angle 1, 7y minus 15. Here's angle 3, and what are we going to do with angle 1 and angle 3? I'm going to do what to them? Add them up, that's right. So what's angle 3? 10 times y plus 11. Now they add up to be what? 180. Okay? They don't equal each other. Now, once in a while on a problem in the book, you might get some angles that are equal to each other. All right? But 1 and 3 are not those angles. 1 and 3 do not equal each other, but they are supplementary. Everybody with me? Let me know if you don't understand what I'm saying here. Well, it's not the answer, but it is an equation, and what am I going to have to do with this equation? Solve it. Solve it for y. Remember what we talked about earlier? Once I know what y is, I'm just going to plug it in, then I can find angle 1. And I could find angle 3 and 2, couldn't I? Either way. All right? So now we got to solve it. This is why we spent, I said this yesterday, but this is why we spent 2 weeks going over the algebra, so that we could do this problem right here. All right? This is the reason for it. So what am I going to do? We started it off a little bit yesterday, but we didn't finish it. Distribute. Very good. I'm going to distribute the 10 through that. 7y minus 15, just going to keep it. 7y minus 15. Now we distribute. This is a positive 10 times y. What's 10 times y? 10y. Very good. And then it's a positive 10 times a positive 11. So it's a positive. What's 11 times 10? It's really easy. When you multiply by 10, all you do is do what to it? Yeah, stick a 0 at the end of it. So it's 110. No calculator needed, correct? Equals what? 180. All right, now what are we going to do over here on the left-hand side? What's the phrase that we use? We had a worksheet on it. Combine like terms. Very good. We're going to combine like terms or add like terms, however you want to say it, okay? Our worksheet said combining like terms. So let's combine the like terms. Let's do the y's first. So what do I got? I got a positive 7y and positive 10y. Add those up. What's 7y plus 10y? 17y. Right? 7 plus 10. That's all you got to do. Stick the y there. So I'm done with that one. I'm done with that one. What else can you add up? Good. I like that. Negative 15 and 110. Okay? You may or may not be able to add that in your head. Can anybody do that in your head? What if that was a 10? What would negative 10 plus 110 be? It'd be 100, but it's a 15. It's 5 more, right? So it's a 95. So plus 95 equals what? 180. I just added like terms. Okay, I added that one and that one together, and I got a positive 95. If you want to put that into a calculator, I guess that's okay. I'm fine with that. You could do that. Now, we got to get y by itself. 2 more steps. So this is one of those multi-step problems, right? Yeah, get rid of the 95 by subtracting a 95. That's right. So we come over here, we subtract a 95 from this. Somebody do that. What would that be? Well, let's do it. Borrow 1 from there. That's a 5. That's an 8. 85. Is that right? 85. That cancels. What's this? 17y. Yeah. Divide by 17. Again, if you can't do this part in your head, just put it in a calculator. But it comes out to be even, nice and easy. That's 5. Yeah, you can use a calculator on a quiz. Yep. Okay, so y is equal to 5. Am I done? Is that my answer? Do I go on to the next problem? No, I got a lot more to do, don't I? All right. So this is a big deal problem. All right. This is not something that you do in 2 seconds and you go on to the next one. There's a lot of stuff you got to do here. So first of all, you had to do the geometry. What was the geometry? The geometry was understanding that angle 1 plus angle 3 adds up to 180. Right. So then I take angle 1, then I take angle 3, right, which is the same thing as angle 2. Right. That was again part of our geometry. You add them up, you set them equal to 180. Now, this is all algebra, right? This is all just algebra. So you do the algebra, you get what y is equal to. Now what I can do is now I can start solving for some things. Let's get rid of this. Let's get rid of this. Give me some room. And let's do this in another color because the black and white looks too boring. All right, so let's find angle 1. Angle 1 is equal to what? What do we do to find angle 1? I do what? I go 7 times what? 5, right, because I just found what y was, okay? Did all that work. I got y is equal to 5, so I put the 5 in for that y. So I go 7 times 5 minus what? 15. Now I do my math. 7 times 5 is 35. 35 minus 15 is, whoops, daisy. It's 35 minus 15. You can do that in your head, can't you? What's that? 20? And this is an angle, so it's not just 20, it's 20 what? Degrees. Okay, 20 degrees. So that's what angle 1 is. So let's go over here on our picture and put a 20 right there. That should really help us. Remember I said earlier, once you find one of those angles, the rest of them kind of all fall in place. So let's see if I'm actually right on that. I tell you what, there's another, we'll get back to that in a second. I just saw something that I should have said. Do you see how this is 90 degrees? What did this theorem, that perpendicular transversal theorem, say? It says if you got parallel lines and my transversal is perpendicular to one of them, then it has to be what? Perpendicular to The other one, right, the other line, the other parallel line. Everybody see that? See how D is perpendicular right here? It must also be perpendicular right there. So without doing any math at all, what's angle 5 equal to? 90 degrees, okay? So there's one of my answers. And I could just look at it and I could have done that right off the bat, couldn't I? Without doing that angle 1 and 3 thing, I could have told you that angle 5 was 90 degrees. Because if it's perpendicular here, then it's perpendicular up here. So that's 90 degrees. Exactly right. That's good. That's the next thing I was going to do. Remember I said everything starts falling into place? This is where I'm talking about. So this right here is also a 90 degree angle, isn't it? All right. So I already know part of that angle. That's 20 degrees. How do I find the rest of it? It's not 80. What am I taking 20 away from? 90. So I'm going 90 minus 20. What's 90 minus 20? It's 70. All right. And that's angle what? 6? So angle 6 is 70 degrees. I'll circle that. So I'm going to write it right there. So that's 70 degrees right there. And what did I say angle 3 was? It's the same as, well, I didn't say angle 3 yet, did I? I did say angle 1. But remember, what's true about angle 1 and angle 3? What do? They add up to 180. So how do I find angle 3? Exactly right. So I go 180 minus 20. And that gives me 160. So that's angle 3. So angle 3 equals 160. Now notice, I got a bunch of different answers here. In fact, I got 6 different answers I have to put. So look what I'm doing. I write angle 3 equals. I write angle 5 equals. Angle 1 equals. Angle 6 equals. Everybody see that? So don't just don't do it in your head and write down 160 somewhere. It's degrees. Okay, make sure you tell me what it's equal to. All right? Go ahead, Neil. That's right. 2 is the same thing as 3, isn't it? So I could find 2 without doing any math at all. Right? So since I know angle 3 is 160 degrees, tell me what angle 2 is. It's 160. Give me a reason why. Why is it 160? Because they are what? Yeah, they're the same thing, but give me a good reason. They're vertical angles. The reason that they're equal to each other, the reason that they are the same thing, is that they're vertical angles. So that's 160 degrees as well. We only got one more thing to find, don't we? Let's circle that. What's the only thing we need to find now? Angle what? 4. Oh, I didn't. Yeah, angle 1 I got already. So angle 4. Look at angle 4. You could just look at it and not do any math at all. It's 20 because, look at this. Everybody look up here. That angle right there and this angle right here, what's the relationship between those angles? They're corresponding angles. Very good. Okay, they're corresponding angles. What did we say about corresponding angles? They are equal to each other. They're equal to each other. Let's not say the same. All right? I know what you're saying, and I get it, and it's not that far off. But when I say they're the same angle, is this angle right here the same angle as this angle right here? No, they're in different spots. This one's up here, this one's down here. So they're not the same angle, but I know what you're getting at, but they are what to each other? They are equal to each other. The measure of the angle are equal to each other. Do you see why I'm being a little bit picky on that? Because they're really not the same angle, but they are equal to each other. And I get it. I get why you would say the same. So that would be 20 degrees right there. What if you didn't realize that that was corresponding to angle 1? You could have done what, Neil? You could have looked at that 160 and said what? To find angle 4. Or this 160 right here. What do they make? Make a straight line. So you could take 160 away from 180 and you still get 20, right? So it works a couple different ways, right? This and this are equal because they're corresponding. Or you could say, oh, if that's 160, 180 minus 160 is 20. Why 180? Because it forms a straight line. All right? So I still got to write down angle 4. Angle 4 equals 20 degrees. Do I already have it up there? No? I do? Oh, sorry. I was looking at this. Yeah, you're right. I do. I already had it up there. So angle 4 is 20 degrees. So that was a big deal, that problem right there, wasn't it? Okay. Look, here's what you need to do. All right. Some of you guys are probably sitting there and like, there's a few things about that I understood you was saying, but I don't know if I get that whole thing. I don't know if I could do that whole thing by myself. You know what you should do? You should do what? You should go back to the video. All right. I did the whole entire thing for you. I think I gave a pretty decent explanation of it. Right? Go back to the video and then write it down yourself. Write down the problem to begin with, okay? Then try it yourself without looking at the video, okay? Just write the problem down. Try to do as much as you can. Once you get stuck, then what should you do? Then you go to the video to that spot. You don't have to sit there, however long this took, 20 minutes or so. You don't have to sit there and watch it from the very time it starts to the time it stops. Just scan through it, get to the part where you got stuck on, okay? And you're like, oh, that's right, whatever, okay? And then go from there. If you get stuck again, then go back to the video to the place where you got stuck and watch that part of it until you figure out how to do it. That's the only way you're going to figure this out, okay? This is the kind of stuff that you're going to need to expect the rest of this year, okay? This style of problem, all right? It's not always going to be parallel lines cut by transversal. But it's going to be this kind of thing where they give you an angle like this, where they put a Y or an X or whatever letter they use, okay? And then you got to look at it and say, hey, what's the relationship? Are they equal to each other? Maybe they add up to 180. Maybe they do something else. Maybe they add up to something else, okay? You've got to be able to do stuff like this. This problem right here, in a nutshell, is what geometry is all about. It really is, okay? Again, it's not always going to be parallel lines, but it's really important. It's super important, okay, that you know how to do this on your own, all right? So that's what you got to do. You've got to put some time and effort into it. I know what some of you guys do. I see your test grades, right? I see some of the homeworks. And it just looks like you're just writing stuff down just to get a 5 out of 5 on the homework, and you're not really trying it, okay? I'm telling you, if you put some effort into this, and you put some time into this, you go to the video, right? You go to the part that you didn't understand, you watch it 2 or 3 times, and then finally, hopefully anyway, finally it'll start clicking. And then you can go from there. And then when you see another problem like this, it shouldn't be that big of a deal, all right? I don't think they're going to give you something this difficult to start off with, okay? They'll probably start off a little easier, then maybe towards the end, they'll give you something a little bit more involved like this. But let's write down what the homework is. You have your lesson plan thing, but I'll write it down anyway. So here it is. It's section 3.1, and you got about 15 minutes in here to work on this, so it's at least a good chance to get started on it. You probably won't have it finished, but at least you get started on it. There it is. Okay, it's 1 to 21, page 111, section 3.1.